Hello. So we've been asked to find the roots of this. So let's say the question is explicitly find roots. It's a cubic, so we would expect there to be 3 roots. In order to find the first root, we would, back in the day, do a bit of trial and error. So we would go f of 0, then we would go f of 1, then we go f of minus 1, and we go f of 2, and then we would do f of minus 2, and so on and so forth until we got our 3 roots, or indeed until we got a root anyway. And then we could use that in a manner that you would see in a second. So and before we start that kind of crazy trial and error system, we might kind of use a tool that we will have with us in our Leaving Cert, namely the calculator. And we're going to input this function into it. So we go mode, and we want to input a function, so we hit 3 table. And that gives us here 3 alpha x cubed minus, so we're using the alpha function here because the letters we want are in red, so we go alpha x, and then we want to square that, minus 22 alpha x plus 24 equals, and let's say we were going to do it the integers, so let's say we're going to start at minus, I don't know, be very mean, the Leaving Cert start at minus 5, but anyway, we went down to 5, okay, and we want to go up in steps of 1, yeah, that seems okay. And we know that f of 0 now is 24. We now know f of 1 is equal to 4. We now know that, and I gave the game away there a little bit, minus 1. F of minus 1 is 42. F of 2 is 0. And f of minus 2, just for completeness, is 40. So we see there's one root in here, namely this guy here, because when we input a number, we get out a 0. So therefore, x equals 2 is a root. That's pretty cool, because using our factor theorem, we now know that x minus 2 is a factor. And now it's plain sailing, so we now go x minus 2 into this guy here. So we're dividing a factor into a function. So we will expect it to go in evenly first of all, but as well as going in evenly, we will also expect it to go, we'll expect the answer up here to be also be a factor, and that factor will have roots and so on and so forth. So we know it's going to go in there 3x squared times, that's 3x cubed minus 6x squared plus 0x plus 0, and we can then subtract this row from this row here, so that's a minus and that's a plus and that's a minus and that's a minus. These guys are gone, and that's 5x squared minus 22x plus 24, and then up here we're going to write in a 5, and that's going to give us 5x squared, no, 5x up here, sorry, 5x squared, yeah, and then minus 10x, and then we have plus 0, and then we do our sign change, plus becomes a minus, and these guys are gone, and we're left with a minus 12x plus 24, and then we have to put in a minus 12 up here, yeah, so that's a minus 12x plus 24. And just for completeness, we come along and we change this guy here to a plus and this guy to a minus, and then we get a 0, and that's brilliant. So that tells us, that's kind of reconfirms this guy here is a factor, which we knew anyway, but it's kind of nice to confirm it. So we have no remainder, and most importantly, we have another factor up here. But this factor up here, plus 5x minus 12, I think we can factorize him down again, can we? Let's try that. 3 x and x, and can we do maybe a 4 and a 3? We can, 4 and a 3, so he becomes a plus and he becomes a minus, and that looks good to me. So our roots are x is equal to minus 3, or x is equal to 4 over 3, or x is equal to 2. Yep.